This is chapter 12. Chapter 12, lesson 2, adding rational numbers. So it's adding fractions and adding decimals. What we're doing is we're just taking a lot of the things that we've already been working on. We're just building our skills so that we just have more tools in our math toolbox. Remember, our big thing is we need to be able to problem solve and we need to be able to communicate. All that's what we're working for. The better prepared we are, the more tools we have, the more we refine those tools, the better we will be able to problem solve and communicate. The big ideas for this lesson, we are adding rational numbers. The big idea is that we use the same rules that we've been using for adding integers, except now we stack those rules on top of the rules that we already know for working with fractions and with decimals. So with fractions, we know we're adding the top numbers, we keep the bottom number the same. On decimals, we line up the decimals, but we still we've got to use those rules of adding and subtracting integers. So let's take a look at this. I started my notes, and then I thought I want to give you time to write also. So we've got this is on page 250. I'm sorry, 526. I need to slow down and let you guys write and let my brain work because it's early morning for me right now. That's not too early. It's 7:35. Lesson 12:2, adding rational numbers. To add rational numbers, this is our the big idea is we are going to use the same what rules for signs you used in integers or for integers. So get this in your notes, if you will, please. To add rational numbers, rational just means fractions, something that you can make into a fraction. To add rational numbers, use the same rules for the signs you used in the integers. All right, so just like a quick review. For example, if we have, like, say we have integers, and I'm adding, let's see, I'll say -3, let's see, +5. I'm going to add, I'm sorry, the signs are different, so I'm going to subtract the absolute value and keep the bigger sign. So I'm going to subtract 5 minus 3, which is 2, and keep the sign of the bigger absolute value, which is positive. Okay, so that's the way integers work. But when we're working with fractions, rational numbers, you might say 3 eighths plus 5 eighths. It's going to be something eighths. So what we're doing is right now we're looking at the numerator and we're saying, okay, the signs are different. So we're going to subtract the absolute values, keep the sign of the bigger absolute value, which is positive, and now my answer, instead of 2, it's 2 eighths, which, by the way, simplifies to 1/4. All right, that's my example. Let's do another example like that. I'm going to do let's just have the other one. So let's say I have 3 plus a -5. Well, that's the same thing. The signs are different. So I'm going to subtract the absolute values, keep the sign of the bigger absolute value, which is negative. All right, you see how this is working? If I'm working with rational numbers or fractions, same thing. I'm going to say 3, we'll go ahead and use eighths again. And then we've got this time a -5. Well, when you add fractions, you keep the denominator the same, and then we add or subtract the numerators. There's one of those little skills that we've been working on. We subtract, even though we're adding, we subtract the absolute values, keep the sign of the bigger absolute value, which is negative. So this is correct, but then simplified, it's going to be -1/4. All right. So what I notice here My screen is going everywhere. Is that they go right into these? They're going right into these numbers that have uh, they're irrational or improper fractions. So and they're also using different denominators or yeah, different denominators. So this book is already assuming a lot of things that you know. You know how to work with improper fractions. You know how to change these things into like denominators. So let's do this for example 3. This time I'm going to use right now I'm going to assume you know how to do the integers. Let's go into one of these fractions. I'm going to actually use the same one that they did. So I'm going to say negative 8/3 plus 5/6. All right. You know that I like to use this line as my fraction bar. You can if you try to make it too small. I mean, like if I did this, like if I had negative 8/3, I've got to cram a lot of stuff into that one little space, that one line. So I like to kind of spread these out. All right. So the book knows that you cannot add thirds and sixths. So they're assuming that you know how to make these into common denominators. So we can make both of these sixths. It's addition, but this is no longer 8/3. So I've got to double that to make thirds into sixths. So I've got to double that and make that into sixteenths. That stays the same. All right, see, the book assumes this. You know this. I don't assume that. I assume that we can forget if we don't practice. All right, that's why we keep practicing. I'm not doing 6 plus 6. I'm saying these are how many sixths we're working with. The signs are different. All right, so I'm going to subtract 16 minus 5, which is 11. And I'm going to keep the sign at the bigger absolute value, the bigger distance from 0. All right, and this is correct. Now, the book is assuming another thing that you know how to do, which is turn improper fractions back into mixed numbers. So I can assume that. And I'm going to go ahead and make a big 1, and that's going to be negative 1 and 5/6. I kind of jammed my work in there together. If you need to work this out, you can do it on a calculator, or you can just go, well, I can divide 11 divided by 6. I can get one group of 6, and there are 5 left over, so it's 1 and 5/6. The negative goes on the front of the 1. My goodness, textbook. You sure are assuming a lot of stuff. These are the things that the book is assuming. You know how to add fractions. Okay, you have to have the bottom numbers that are the same. The denominators are the same. The book also assumes that once you solve a problem, and then also that you know to turn a mixed number into an improper fraction. That's another assumption that the book is making. All right. So these are why it's important to learn these little tiny skills so that you can build those up and then solve these more complex problems. All right. So and then it just becomes second nature. You just know how to do them. Now we're gonna take a look at. Let's just do another one of those before we move on to the decimals. I'm reaching way over here for my mouse. If you're wondering what's going on, why is Miller so crazy? Let's take. I'm gonna do example 4. I'm going to use again. They're just actually they're doing everything. If you look at this, they're doing everything where it's like the a positive and a negative and a positive. See, there's another one where they're assuming you know how to turn that into an improper fraction. They're assuming that you know how to turn 2 into 2 over 1. So there's a lot of things that the book is assuming that you know how to do. Let me do something. We're just going to do one with a couple of negatives. I'm going to say negative. I'm not even going to use the book's example. I'm going to say negative 2/3. And I'm going to add to that a negative 5. Oh my goodness. Already, I'm assuming that you know a lot of things. This isn't 5/3, this is 5. Okay. So the first thing I'm going to do is I'm going to turn this into a fraction. And I still can't add them. So I'm going to have to find a common denominator, which is going to be thirds. So this stays the same. I'm going to keep that into an addition. It's still going to be negative, except instead of 5 over 1, I'm going to make that 15 over 3. I took that times 3. I've got to take that times 3. Look at all these things that we've been working on, that you are building these skills. We know that the denominator stays the same. On this one, though, think about our rules of addition, our rules of integers. If the sign is the same, you add the absolute values. 15 plus 2, 17. And you keep the sign. This is negative. If these were both positives, you would add them. It'd be 17, and then you would keep the sign, which would be positive. This is correct, but I'm going to go ahead and simplify. Again, I assume that you know how to do this, but I'm going to go walk through it with you anyway. I don't need to use my negatives because I'm just trying to figure out what my whole number is, and then it's going to be something thirds. So I know that this is going to be negative. I can get 5 groups of 3. I'm going to have 2 left over. So that's 5 remainder 2, which is 5 and 2/3. So it's going to be negative 5 and 2/3. All right, so far so good. That's a really quick look at when we're working with fractions. I'm going to go into the second part of this lesson, which is adding rational numbers. I may have to break this up into 2 lessons because then they have us evaluate expressions. This book is assuming we know so many things, but let's go ahead and go back, and we're going to do a couple problems that are adding rational numbers. All right, so it's going to be rational numbers meaning decimals. Okay, so the fractions are rational numbers. Again, this is still on page 256, but now we're going to be looking at rational numbers, which are decimals. I'm going to give myself a new page for this. Are we in example 5? I think we are. So the last one was fractions. These are decimals. So we're going to add rational numbers. But this time we're looking at which are decimals. I'm going to go ahead and use the book's example. They wrote negative 4.05, and they're adding 7.62. All right. Again, there's a lot of things that we assume that you know. But first things first, we are looking at the integers rules. So we've got a positive and a negative. So that means we're going to subtract the absolute values and then keep the sign of the bigger one. So we're subtracting the absolute value. That's going to be positive. We're subtracting the absolute values, lining up the decimals. That's an assumption. My answer is going to also have a decimal right there. And then I'm going to keep the sign of the larger absolute value. So this answer is actually going to be positive. I'm going to subtract the absolute values, but my answer is going to be positive. So use the regular rules. We're going to borrow. That becomes a 12. 12 minus 5 is 7. 5 minus 0, and then 7 minus 4. All right, so this equals 3 and 57/100. I can do this all in my head. I can do this on a calculator, but you remember we are problem solving and communicating. So somebody who reads this can look at this and go, oh, they're adding, the signs are different, so we subtract, and then we're going to keep the sign of the bigger absolute value. Let's do example 6. I am going to use, once again, one of the book's example problems. This time I'm going to say negative 8 and 15 hundredths. And then I'm going to add 8 negative 4 and 3 tenths. So the signs are the same. That means I'm going to add the absolute values and my answer is going to be negative. Keep the sign. I want to line these up. And I like to keep the bigger absolute value on the top. 8 and 15 hundredths. 4 and 3 tenths. Even though they're both negative, I'm going to add the absolute value. My answer is going to be negative, but I'm going to add the absolute values. This is another assumption the book knows that you can put in those placeholders. 5 plus 0, 1 plus 3 is 4. Don't forget that decimal point, and this becomes a 12. So my answer is negative 12 and 45 hundredths. All of these problems, listen to me. All of these problems, we just have to slow down. I don't want you to rush through these. It takes a while to practice. All right. If you're on a basketball team, you're not going to finish a practice in a minute. Okay. If you're a musician, you're not going to finish your music lesson in a minute. It takes time. It takes practice. Slow it down. And then the more you slow it down, the better you're able to do it more quickly. It feels more natural. Then you can communicate it. Okay. Problem solve, communicate. Let's do one more. And then I'm gonna stop and I'm gonna give you some practice problems from the last page here. But let's just do one more problem with let's see. I'll do this one. 65 hundredths. I'm going to add a negative 2 and 75 hundredths. Negative 2 and 75 hundredths. The signs are different. We have a positive, negative. So that means I'm going to subtract the absolute values. I always like to keep the bigger absolute value on the top. I'm going to subtract the absolute value and keep the sign of the bigger absolute value, the bigger distance. So my answer is going to be a negative number. 5 minus 5 is 0. 7 minus 6 is 1. 2 minus 0. Okay, so I could write my answer as negative 2 and 10 hundredths, but I'm going to go ahead and simplify that and write negative 2 and 1 tenth, which is the exact same thing. What I want you to do, my precious angels, is to go, okay, so I'm not going to do example 3. I'm going to wait and then do that one tomorrow. But we're going to turn to page 528. All right, I'm going to show these problems to you. The ones I want you to do, I'll probably clip and put those in the video or below the video. But here's what I want you to do for today to practice. We're going to work with some fractions, and then we're going to work with some decimals. I want you to do, let's do 4. Let's just do 4 through 7. 1, 2, 3, 4. These actually give you the same. You don't have to convert. They're both in 12ths. Those are both in fifths. These we're going to have to line up. 7. 7. You're going to have to make those both into 14ths. Let's go ahead and do. Let's see. I want to do one more decimal. Let's do number 10 also. So we're going to do 4, 5, 6, 7, and then 10. And I would like you to go ahead and try 13 and 14. Tell me what they did wrong in there. All right, did you get all that? If not, just roll it back and then go ahead and pause it. I want you to do 4, 5, 6, 7, 10, 13, and 14. 7 problems. That's a nice round number. It's a nice prime number. That's it for today. So this is adding rational numbers. And tomorrow I'm going to do, I'm going to do part 2, which is, what did we say that was? Those are evaluating expressions. So we're going to be using variables. Wow, this is a lot of good stuff. Let me know if you have any questions on those practice problems for today, and hope you have an awesome day.